And I got a PhD in aerospace engineering, and my background in aerospace engineering is primarily focused on guidance, navigation, and controls, which, to simplify it, what I'm really passionate about is getting rid of the human operator, because in my opinion and in my point of view, human operator sucks and is prone to making mistakes. So by removing the human operator from the loop, we can push the boundaries of what our technology can do. And because of that, I've primarily worked in different industries that was focused on doing that. Prior to starting Space Ride, I was basically an early employee of Cruise Automation, the self-driving car company that was developing technology in San Francisco. And as an early employee there, I got the opportunity to develop and lay the foundation of all the algorithms that to date is still driving cruise cars on public roads of San Francisco. And that also gave me another point of view. At Cruise, we advanced really, really fast. And part of that was attributed to top level engineers that we had, hard working and like work ethics that we had. But there was another facet to it. And that was how quickly we could develop algorithms, we could develop technology, and in a matter of a few days, we could test it in the target environment, which was public roads of San Francisco, and get feedback and re-improve and redo, reiterate, and improve the technology. And that's something that, in my opinion, is missing from space industry. And that's what we need to address to move space industry at the rate other industries have been moving on the planet. Now, before we take a deep dive into space transportation, the first question that I want to answer is that why do we even care about space? And let's take a look at the issues that we are having today on the planet. One of the biggest issues is energy and energy shortage. Different sources of energy that we use, primarily to date, it is fossil fuel and the shortage of that. This is further exaggerated since February of 2022 when Russia invaded Ukraine. On top of that, shortage of some key materials and minerals that we have on the planet. Everyone is interested in getting their hands on an electric car. But one of the key things that we don't have is enough lithium, enough nickel, enough cobalt. And many of the places that these materials are mined at are not following the best standards to make sure that we are not harming the environment. As much as many of us want to switch to EVs to protect the planet, methods at which and ways at which we are mining these materials to build EVs are flawed and are harming the planet. Now, on top of that, let's think about activities that we do in general that are contributing to continued increase of the global temperature. Cloud computing, to think of. All those server storages that we have, the heat generated by them is contributing to continued increase of the temperature of the Earth. And how can we solve all these problems? Only if there was one solution to fix them all. And in fact, there is. Now, let's take a look at recent activities that we have seen in space. And I'm not going to name companies because I do not want to advertise for company A or company B. But if you have been paying attention to what has been happening in space, one key thing that we notice is manufacturing in space. There are ways at which we can manufacture alloys, which it's impossible to do on the planet, in part, mostly because of operating in microgravity environment that allows us to get to alloys that are superior to what we can do basically on the surface of the planet. Or look at, for example, companies that are looking to build uh, fiber optic cables that are going to be, again, superior to what we can build on the planet. On top of that, a lot of companies, I'm sure you have heard of, are looking into mining different celestial bodies, from going to asteroid belt and mining platinum, or going to the surface of the moon, mining water that can be broken into oxygen and hydrogen, which itself is going to be used for rocket fuel and oxidizer to propel us to deeper spaces in basically our solar system. And on top of that, mining the regolith on the surface of the moon, potentially for use in space or bringing it back to the planet for harvesting iron or other minerals that can be harvested. On top of that, other players are being attracted to space. Think about pharma. We are looking into building the purest form of insulin that is, again, impossible to do it on the planet in space, which is going to solve many problems that people are experiencing at the later stages of their lives and developing basically resistance to insulin. People are looking into technologies and ways of doing human reproduction in outer space. We can even grow organs, human organs. From stem cell of the patient, we can grow a functioning human heart, human kidney. And instead of grandma having to wait for someone else to die, for them to potentially get a heart, which may or may not be a match to what they need, we can actually grow a fully functioning human heart in space and bring it back to the planet. Something that is impossible to do on the surface of the planet. And lastly, what is going to solve many of our problems is energy generation. Access to 24/7, year-round solar energy that we can harvest and we can microwave again to the surface of the planet. These are all the things that are happening in space, and all of which is part of a trend that, if you look at the numbers that were published by Euroconsult in 2022, more than $400 billion was the size of space economy in 2022. And by some accounts, space economy is going to grow past $1 trillion mark in 2030 or years beyond. But what's clear, and there's no doubt in that, is that space economy is growing at a super rapid pace and is going to grow to past $1 trillion industry. And with that, with many of these new applications that are coming to this industry, one of the things that we always have to remember is that everything that we do in space needs a ride to space, some form of access to space, movement in space, and perhaps coming back to the planet. But up until now, majority of our missions in space was that let's launch a satellite, let's take pictures of the planet. Let's launch a constellation of satellites, provide data communications. This was majority of what we used to do. But now this is changing because people who are doing all those pharma applications, they actually don't need to stay in space indefinitely. They need to bring the final product back. They need to protect themselves from radiation that we are going to be exposed at in space. So potentially lower elevation, lower orbits are better for them. Now, people who want to go to asteroids might have to go deep into space. They might have to be launched into a different inclination than the one that, for example, majority of Earth observation satellites are going to. Maybe sun synchronous orbit is no longer going to be the hot destination for our space activities. When all of these new activities coming together, each requiring different mode of operation, each requiring different way of accessing space. That brings me to why we need transportation in space, but transportation in a way that we have not had so far. I'm not suggesting that we don't have a way of getting to space. Of course, we have SpaceX. And the fact that we are talking about growth of space, future of space, is because of SpaceX, is because they have lowered the cost of getting to space so much, and the frequency has been increased by so much that we can think about all these crazy ideas. But that's not enough, because SpaceX, for all intents and purposes, whether it is Falcon 9 or when we have Starship, and it's not going to change, is going to function like a bus. Set schedule, set destination, relatively cheap price, which if someone has been paying attention to the past 2 years, the prices have been going up as well. So the lower price that everyone has been talking about and we're expecting to continue going down is actually going up. And it has the inherent flaw that it is, practically speaking, a public transportation system. Set schedule, set destination. Now, if the destination and schedule works for you, perfect. But if it doesn't, you have to resort to other options. Of course, we have micro launchers. And I'm not going to, again, name companies because I don't want to say this company is better than that company. But one thing they all have in common, yes, they do offer flexibility of your schedule, your destination, but prices are so expensive that many of these applications that we are doing cannot rely on those micro launchers. And some people came and say that, oh, what about OTVs, on-orbit transport vehicles? And in my opinion, they're like those dudes that carry their bicycles on their shoulder to a bus, put it in front of the bus, for them to go to the bus stop, drop off, and then they have to cycle to the final destination. It's not very convenient. And on top of that, OTVs that we have had so far are slow, meaning that it often takes close to 4 to 6 months to get from the drop-off orbit to the final orbit. And with the new ruling that came out by FCC that limits the lifespan of operation in LEO to 5 years, if you waste 6 months going from drop-off orbit to the final orbit, that's 10% of your effective orbital lifetime. That's 10% less ROI that you're going to have on the investment that you had. That's not good. So what do we need? Because yeah, it's not that we are not getting more launches. SpaceX had a phenomenal year last year, 62 launches. But the issue is more than 50 of those were for Starlink, not from folks like us. And the other ones were primarily launched to sun synchronous orbit. So what about the dudes who want to go to some other orbits? And that's what we need to address. We need a transportation system that is going to combine launches from the ground to transportation in space. And the first step is that a lot of people are saying that launch from the ground is solved. We actually don't need more rockets. That's incorrect. We need more and more and more rockets to be launching from the ground to space, to different destinations in space. Because again, space is big. And unless you are moving in the same inclination that you have put in, moving from one inclination to another inclination is in fact very expensive in space. So we need launches to go in all different ways from the planet to space. But once we get there, now we need to be able to roam around. And that's the second part that I'm most interested about. We have so far built a constellation of satellites. But now imagine, combine that constellation of satellites, build a constellation of rockets. These rockets have propulsion on board. I'm not talking about electric propulsion. Electric propulsion is good. I'm not here to say electric propulsion is bad. But again, electric propulsion is slow and time is precious. Imagine you want to go from low Earth orbit to low lunar orbit. If you're operating on electric propulsion, months and months that it takes for you to do this journey, it means exposure to radiation that you do not need. Or if you want to stay in low Earth orbit, it means, again, 10% of your orbital lifetime going to waste. So we need a constellation of rockets powered by high power chemical propulsion. And lastly, we need to make them reusable and refuelable. I'm not talking about bringing them back to the planet, refueling and launching them, because once we put them in space, we have once overcome the gravitational well of our planet. Why are we going to bring it back and launch it again? That's dumb. Let's build this constellation of rockets. Let's make sure they have high power chemical propulsion. And let's make sure that they can be refueled in space and they can be reused in space over and over. Now we are thinking of building a transportation system in space that can take something from low Earth orbit to higher orbit, that can take something from low Earth orbit to lunar orbit, bring something back from lunar orbit to low Earth orbit, potentially do propulsive braking to bring things back to the surface of the planet, potentially driving itself to debris that we are having a lot of problems with, grabbing those and do propulsive braking again to put them into a re-entry orbit such that they get burnt up and re-entry into atmosphere. That's what I'm talking about. And for this transportation, we need to make sure that we have key elements, that there are a lot of companies that thankfully are working on this. Number one, refueling in space is a must. Number two, we need to look into guidance, navigation, and controls technology that are going to help us go past low Earth orbit, that are going to help us move past the point that we do not have the support of GPS satellites, reliably going to the moon and coming back. And we need to look into ways of bringing things back to the planet that is not necessarily relying on propulsion and slowing down. We need to reinvent technologies that are going to be used for basically heat shields, potentially heat shields that are powered by putting in cryogenics under the surface of the re-entry probe to cool it down, so we don't have to do the amount of inspection that we needed to do for a space shuttle. And these are key technologies that we need to look into that. And when that day comes, and that day is coming, we are going to basically lower the bar for accessing space. Because if you remember, from what I said, my experience of working at Cruise was that very quickly we could build an algorithm, we could build a technology and test it in the target working environment. That's exactly what we need to do for a space to progress at a much faster rate. We need to lower the bar. We need to eliminate the bar of accessing space. And that doesn't mean just cheap access to space, it means timely access to space. We have to have frequent rides to different inclinations. We have to have transportation system in space that takes us from drop off to various locations that we want to go. And companies don't have to spend so much time thinking about what if something goes wrong in my test, because the cost of access to space should be so low and the frequency should be so high that they can say that, if this fails, doesn't matter. I'm going to build another one, try it again, and then build another one and try it again. So and so and so and so until I get it working. Because the cost of accessing space and the frequency at which we can access space is so good that the time that I'm going to spend on the planet re-engineer that spacecraft, that satellite, is not worth it anymore. And that's the day that we are going to see innovation is going to happen. When that day comes, when we have that transportation system, that's going to be like iPhone. The way iPhone works for so many of businesses that we are using today, iPhone is what created Uber. iPhone is what created Instacart, is created Instagram. One device with the opportunity to develop your app at such a low cost created so many businesses, so many industries that we owe our on-demand, beloved, whatever thing that we are using to Steve Jobs and his vision. And for space, we need this transportation system. It's a two-space transportation, frequent launches from the ground to space in all directions. And that network of rockets, that constellation of rockets in space that is refuelable and reusable, that is going to be the platform on which development can happen, innovation can happen. And when that happens, then very soon we are going to have human hearts grown in space, ready for you to be used. So maybe we can extend our lifespan from 80 to 180 to maybe 280. Maybe we can have so much energy that we don't even need to harvest oil. That would be a brilliant day. Maybe we have so much energy that the cost of making fertilizer on the planet, for making food, for growing food, is so low that everyone is fed. That would be a brilliant day. And we don't have unlimited resources in space, but the only place that I know that we have close to unlimited resources is in fact outer space. And the only way to take advantage of that is that transportation network and that transportation system that I explained. And that's what I wanted to share with folks. I hope this gives people ideas and concepts that they're going to go and build fancy tech and advanced tech. And maybe one day, we'll see that a lot of advancement is happening because of just that transportation system.
Thank you, Sohrab. Well, we really appreciate your thoughts on space transportation and mobility. I mean, there was more than that. It was really inspiring to listen to you as well. And we still haven't got to the published 13 patents. Maybe we can do that for another episode sometime in the future. I'd love to know more about that too. But from Thomas also in the chat, he says, I like the vision of Sohrab as well. So people really enjoying, I mean, the points of view that you're bringing. And we have also a few questions here. So from Gonzalo Esteves, he asks, do you mean large space tug versus a rocket?
I refer to them as rocket because I feel like space tug, the name has been used often, and it in people's head, it has a definition. Yes, what I meant is a large space tug. Size necessarily doesn't matter. What matters is that it should be reusable and it should have high thrust chemical propulsion. So the time of travel, for example, to the moon, for this system to work, you need to be able to go to the moon and back in 2 weeks. Whatever it takes to do that, maybe one day someone can say that, hey, I have this brilliant electric propulsion that would allow you to do that. Great, bring it on. But what I know so far that is going to allow for that to happen is chemical propulsion, high thrust chemical propulsion. It doesn't have to be like in kilonewtons, like low kilonewtons is like high kilonewtons. We don't need that. Even, for example, 1 or 2 kilonewtons is more than enough, depending on the size, of course. But it should be reusable, it should be refuelable, and it should have that high thrust, so it lowers the time to travel. And you can call it tug, you can call it OTV, or you can call it the constellation of rockets.
Thank you, Sohrab. And we have a following question also. For all of these many orbits that you talked about, who would be the customers for these orbits? Also coming from Gonzalo.
So again, as I mentioned, a lot of companies who are doing manufacturing in space, so far, majority of their application is for use case on the planet. So it has to come back. And for them, they don't really need to go to 500 kilometers or 600 kilometers to get the benefit of microgravity. They can get it at 200, 300 kilometers. So these are one example. No rocket goes there because you have a short orbital lifespan. And in fact, that's actually good for these applications because you get the natural decaying orbit that is good for you. So you don't need even to have propulsion on board to get out of orbit. If you do the right calculation, you get out of the orbit at the right time and you go and pick it up. So that's one thing. The second thing is a lot of applications are being developed in orbits other than the polar and sun synchronous. Specifically, if we are talking about going to the moon, there are different ways that we can go to the moon. And we can go taking advantage of polar orbit, we can go taking advantage of lower inclination orbit. And that's another thing that we need to do. Back when I was running Space Ride, we had a customer who was looking into doing racing in space. And there was an announcement back in January, I think, about that they wanted to do satellite racing in space. Again, they wanted to go to a lower Earth orbit. They were talking about lower than typical 500 kilometer because they didn't want their operation to be a danger for other assets that we have in space. Or, for example, we had a potential customer who was talking about going to a specific inclination that was particularly designed for building a constellation of communication satellites to provide very quick communications between Europe and North America for, again, an application that they had in mind that I cannot basically say what the application was. But we are getting into the day and age that space application is going to be very, very specialized. Each application is going to be different than the other one. And because of that, they're going to require different orbits. And now that we have that, we need to be able to go into different inclination. And that's the problem of taking advantage of only what SpaceX has to offer, because again, majority of the rides are going to the same orbit. And the biggest cost in space transportation is plane change or changing the inclination of the orbit. So if we have rockets going into different directions, for example, when relativity is online, when ABL is going to be online, hopefully folks at Virgin Orbit figure out how to continue their operations. Rocket Lab has been very successful. So more and more that we are going to see happening, and hopefully they're going to lower their cost over time. You're going to see going into different directions. And then on top of that, that in-space transportation can take you further deeper, maybe offer some smaller change in inclination. And that is where we get the flexibility. You can think of it as Uber that you use after you use a plane. You fly from, I don't know, London to Toronto, and then you land in Toronto, and then you call the Uber. And that part of the in-space transportation, in my mind, is the Uber of space.
Perfect. Thank you for that. Another question that we have is talking about on Earth, we have already enough solar exposure and technology. So why should we do that in space? And see, for example, he uses example of Tesla Master Plan 3, which is probably he emphasizing that there was a focus on scaling both production and the supply chains that supports it. So maybe you can comment on.
So by the time that the solar rays or solar energy gets to the planet, there is so much weakening has happened to it because of it traveling through the atmosphere. So when we are operating in space, we don't have that. We can microwave the energy at frequencies that has the least weakening when it goes through the atmosphere. Second thing is, nowhere on the planet you have 24/7 exposure. Sure, maybe if you go to African Sahara, don't have many overcast days. So from that perspective, it is good, but you still have day and night. But you can go to orbits around the planet that you see the sun 24/7 every day of the year. And that way, you can continuously generate energy and beam it to the ground. The other thing is a lot of controversies going around, oh, you're using this land, although I don't think anyone is doing anything meaningful in African Sahara. So if you convert it to solar farms, we are not doing anyone any harm, but still it's going to be a battle between, oh, this is my land, why are you using this to generate electricity for your people in the US or UK or anywhere in the world, right? Whereas space is for everyone. you can generate energy for everyone in space. And it's going to be free of all those political nonsense that, oh, this is my land, and my land, I don't want you to use it, such and such. And many of those battles we can overcome. And by generating energy also in space, we can have it for our use cases in space. For all those factories in space, biolabs in space, they need energy too. And that's one of the, I cannot say bottlenecks, but limiting factors for a small satellite is that they cannot carry big enough solar panels to power the power-hungry electronics. So if we have a way of, for example, like centralized energy generation in space, that we can pass around energy with just microwave, and then we have receivers that receives the energy and converts that back into electrical energy, then the size of the satellite all of a sudden is not that important from the perspective of energy generation.